Welcome to my channel, STEM Cafe, where we make everything science, technology, engineering, and mathematics easy, fun. We make it easy to comprehend and assimilate. Here, we are treating some questions under forces that fall under moment and some other topics, just to give us the background for ease in handling questions in engineering, mathematics, science, and technology. We start with this. This is part 2 of questions on forces. It says, resolve the forces A horizontally and vertically, B along and normal to the plane, W acts vertically downward. This is the diagram. You can see horizontally and vertically, that is like this. So we are to have it like this. Let's draw it like this and do each force. We have P like this, and it sustains 40 degrees here, and we have 30 degrees. The plane is 30 degrees to the horizontal. Now, let's draw this parallel to this horizontal. You can see alternate angles are equal. So which means that apart from sustaining 40 degrees to the plane, it sustains further 30 degrees to the horizontal. So the total angle here, this is sustains total of 90 and 70 degrees. That is 40 plus 30 degrees. So that is 70 degrees. So that is what P sustains. So if you are to do it horizontally and vertically, along the horizontal, which means that you have P like this, 70 degrees. So this place will be P sine 70 and it's upward. You can see this place is towards this place now. It is P cos 70 degrees. So this is what we are going to have now. This is P. So we have it like this. We are going to have P sine 70 and P cos 70 degrees. You can see this place is also the same thing as this place. So we have it like this. And this one goes this way. Now let's handle that of the W. If you look at the W, it will be like this. The W comes down like this. You can see it comes down like this. So, and this is 30 degrees. If you look at it, it has components along the vertical direction downwards. But since it is perpendicular to this place, it has no components along this place. So, if we resolve it along the horizontal and perpendicular, we have only vertical this thing, component for W. So this is how it goes. W goes downward. So this is W. So this is how we resolve it. You can see it doesn't have any components along the horizontal because it is perpendicular to the horizontal. So at the end, this is what we have. We have the P sine 70, P cos 70, and W downward. So that's all the resolved component. Now let's do the B section. The part B section. That one is very interesting. We have this. So we have P. So we have P like this. 40 degrees. See. This one is 30 degrees. So we want to resolve it along this plane and perpendicular to the plane, like this. So this is what we have now. See. So if we resolve this one, you can see P goes like this. It is going to be P sine 40 here. And upward, the plane, we have P cos 40 degrees. You can see, straightforward. So we have this P sine 40 degrees. And upward like this, we have P cos 40 degrees. So I don't need to draw the P again. So we have resolved it. Now let's look at W. What W resolve component along the plane will be like? See, W comes down like this. And for us to have this component along the plane, we are going to have something like this. Because it has to be like this. That's it. And we still have 30 degrees here. Don't forget. Now, we now have parallel. This one is parallel to this place. You can see. And this one is perpendicular to this one. So this is W. It comes downward. W comes downward. This place is 30 degrees. And this place will be 60 degrees. But from this place to this place is 90 degrees. So automatically this place is 30 degrees. You can see that place is 30 degrees. Now, you can see that W is now the hypotenuse. Along this place now, we have W cos 30. and here we have W sine 30 degrees. You can see it's downward. The two combine to make up this W. So we are going to have something like this: perpendicular W cos 30, and we have down towards down like this, W sine 30 degrees. This alone can make you to understand so many things. So many things. When we come to friction, body moving up the plane, and other forces that act on body moving up the plane. With this, you have already solved the basics of the meter. Now let's go to the next question. Two forces, F1 and F2, act on a body of mass 2.5 kg. F1 has magnitude 5 Newton in direction not 30 degrees east, and F2 magnitude 8 Newton in direction E, east direction. Find the acceleration of the body. Now let's look at it. You have a body like this, 2.5 kg. And we are told F1 acts like this, not 30 degrees east, and with magnitude 5 Newton. And F2, 8 Newton in direction east. We are now asked the acceleration. The first thing to do is to find the resultant of the forces acting on the body. And we can use parallelogram, triangle, resolution of vectors, or even full vector rotation. Okay, let me use vector. This one is 5 Newton and this one is 60 degrees. And this is F1. So F1, we can write it as 5 Newton cos 60i plus 5 sine 60j. F2, 8i. So now the resultant is F1 plus F2, and that is going to give me, let me quickly work it out. So you can see I resolved it, I broke it down, and F1 is this, F2 is this. So R is F1 plus F2, and look at it. So if I want to find the magnitude of R, it does 10.5 squared plus 4.33 squared, and that will give me the magnitude of R. So and direction, tan theta for R, theta R, sorry, it's theta R again, R tan 4.33 over 10.5. So from this, A will be equal to R over N, and that I will get is to be in the direction of R. So on resolving, you can see 11.36 Newton, theta, the angle, the direction is 22.41. So at the end of the day, acceleration is 4.543 meters per second squared in the direction 22.41. It follows the direction of the force. You can see it's very easy, and you can also use parallelogram or triangular. This one is the same thing as resolution of forces that I used. So you just draw it like this, and then you drop 8 like this, 5, 60 here. So then just 8, 5. You can see this is 60 here, 60 here. So this is 120. So R, you can find R, and this is the resultant. You can find it using cosine rule. So you can solve it straight and you get your answer. Now you have a question. On a level table, a toy car of mass 0.2 kg can reach a speed of 0.6 meters per second in 3 seconds from rest. What is the effective pull of the engine? If the car is loaded with another 0.4 kg, how long will it take to reach the same speed? Third part. The car is now placed by itself on an inclined surface which has a slope of theta. We have sine theta equals to 1 over 80. How long does the car take to reach the same speed from rest? Let us assume friction is negligible in this instance, because we are silent about this. So now if you look at it, they told us that initial velocity u is 0 and final velocity v is 0.6 meters per second, and the time taken is 3 seconds. So for us to find the effective pull, we need to find the acceleration. So how do we do that? We say v equals u plus 80. Therefore a equals to v minus u over t, and that is 0.6 minus 0 over 3, which is equal to 0.2 meters per second. So for the first part, effective pull is equal to 0.2 times 0.2, which is equal to 0.04 Newton. That is the effective pull. Now let's look at the car like this. the first part. Let us now see it moving now with 0.2 meters per second. That is if it is alone. But the force still remains the same. F. Now we have 0.2 kg. Now another 0.4 kg is now added to it. The total mass now is 0.6 kg. And we are asked, how long will it take to get to the same speed? This is how we go about it. You can say that F equals ma. In this situation, our A is equal to 0.04 over 0.6. And that is, let's say 4 over 60. 2 over 30. 1 over 15. Yeah. 1 over 15 meters per second. So that's better. We are now asked, how long will it take to get to 3 meters, 0.6 meters per second? In this instance, we have v.6 equals to 0 plus 1 over 15t. 1 over 15t. Therefore, t will be equal to 0.6 times 15, which is equal to 9 seconds. So if you take 9 seconds to get to that same speed of 0.6 meters per second. Now let's check the last part. Now it says the car is now placed by itself on an inclined surface which has a slope of theta, where sin theta is 1 over 8. How long will the car take to reach the same speed from rest? We have been able to calculate that the effective pull is 0.04. That one is clear. And this car, 0.2, is now placed on this place with a force of 0.04 Newton moving up. And we have theta here. Now, we have resolved the first question. From this first question, we can see that this weight will come down like this, 0.2 g. And perpendicular to it, we have 0.2 g cos theta. Along down like this, we have 0.2 g sin theta. You can see. Now, this force is pulling it up. It will first of all overcome this one before it is effective in pulling it up. Therefore, 0.04 will be equal to 0.2 g sin theta plus 0.28. I believe it is clear. For it to give us this at all, it must first of all overcome this one. This pull down, this component of the weight downward will act against the force pulling it up. And we have been told that sin theta is equal to 1 over 80. So 0.2a is equal to 0.04 minus 0.2 times 10 times 1 over 80. So this one is 8. Let's cut through by 0.2. So I have this one. So here 0.2 and here. So a is equal to 0.2 minus 1 over 8. And that is giving me. So a is equal to 0.075 meters per second. We are asked the time it will take to get to the same speed from rest. And what is the same speed? V 0.06 meters per second. And we know that u is 0. So from rest. Then we know our a now to be 0.075 meters per second. Therefore, 0.6 is equal to 0 plus 0.075 t. Or I got it to be okay. So t is equal to 0.6 divided by 0.075, and that gives me 8 seconds. So the time to reach the same speed is 8 seconds. You can see when you can resolve your forces conveniently, you can handle so many things easily. A weightless string, non-stretching, is placed over a smooth pulley. So the ends of the string are attached masses of 2 kg and 1 kg, and both parts of the string are vertical. With what acceleration does the system move? What is the reaction at the axle of the pulley? Now we have it like this, and we have 2 kg like this, and we have 1 kg like this, and we have this like this. We have T here and we have T here. This T moves this one up. This T also acts against this one here. But this one moves. You can look at it. This one gives the effective pull. And this one resists the 2 kg weight. So we have 2 G. We have G is acceleration due to gravity. And here we have G. T is resisting this one, and T is pulling this one. The reaction here, R, will be equal to 2T. Now, let's work it out. The force on this part 1, 2G minus T will give us 2A. Where A is equal to, where 2 is the mass and A is the acceleration of the body here. Now, since T is the one moving this one out, T minus G is equal to A. Now, we can eliminate T by adding these two equations. This is the second part. Now, let's add 1 plus 2. We have G, because this will be subtracted from this. We have G is equal to 3A. G equals to 3A. Now, A is equal to G over 3. A is equal to G over 3. And that will be equal to 10 over 3 meters per second squared. Let's do that one again. We are now asked, we thought acceleration to be yes. What is the reaction at the axis of the fluid? Which means that we will need to find T. And from this, we can see that T minus G equals A from 2. And A is 10 over 3. So T minus 10 is equal to 10 over 3. So T equals to 10 plus 10 over 3. And what does that give us? It gives us 40 over 3 meters. So for the reaction R, it was established to be equal to 2T, and which is equal to 2 times 40 over 3, which is equal to 80 over 3 newton. That's the value for R. Very straightforward and easy. If it's objective and you have the A, and easily just say, okay, what are the forces that act against this one? This is pulling it. This one is against it. And what is the total mass? 3. So just work it out straight. So if this one is pulling it down, this one is, you look at it from the perspective that it is a body, a rigid body, where force is acting against one, and the other side is also being assisted by the force. So here, the force that is moving here is 2G. The force that is acting against this one is 1G. And the total mass is 3G. So we have 2G minus G is equal to MA. And what is the M? 3A. So G is equal to 3A. So this kind of working will help in multiple choice questions and whatever. And from there, you can easily get your A. For this one, if you are asked in an examination, I'd rather you do it like this as a theory. For multiple choice question, you work it like that. A car of mass 800 kg is towing a caravan of mass 500 kg at a steady speed. Road resistance and others are estimated at 5 Newton per kilogram of mass for each vehicle. What is the tractive force of the car? If the car and caravan accelerate at 0.2 meters per second squared, what is the new tractive force? What is the new tractive force? So let's look at what it is like. We have a caravan of 500 kg and being towed by a car of 800 kg. This one is 800 kg. And this is the engine of this one is giving us the tractive force. Let's put it out. It's giving us the tractive force. Let me make this. Now, we're also told that there are some resistance here. This one we have 5 times 500. And this one is 5 times 800. If you look at it from Newton's third law of motion, just like the one we did last time, when T is drawing this, T is working against this one. So it's like a system. It's a system. Let me just put it like that. It's a system. So you can do it like this. So this T drags it. This T drags this one back at the same time. Then this F is now pulling this one, or you say it's pulling this one and this force at the same time. It's pulling this one and this force applied at the same time. So F for this car now, since the acceleration is 0, so Fa is also equal to 0. Therefore, you can look at this one as a portion of the system. So we have F to be equal to 5 times 800 plus T. And this T is one dragging this one out. T is equal to 5 times 500. So we can see that F is equal to 5 into 800 plus 500, which is equal to 6500 Newton. That is the tractive force, F. You can also look at this straight like this and say, okay, since F is acting like this, consider everything as a whole body. So what is the total mass? 500. So what is the total mass? 500 plus 800. And then this the mass is not even a problem now. The total force resisting this one, as it is moving with constant velocity, A is 0. So we can just add this one and this one, and if you give us this one straight, I believe with experience, we'll get more and more, better and better. Now, if we have acceleration, we are going to have m 0.2 m, and it will be added to this force here now. So we are going to have this F now will be F plus 5 times 800 plus T plus 0.2 times 800. And C will be 5 times 500 plus 0.2 times 500. So you can see that that is the component that the acceleration. So the acceleration has brought in this one now, additional force here now. So we have F, total F now, since this is our T now, F will now be equal to 5 times 800 plus 0.2 times 800 plus 5 times 500 plus 0.2 times 500. So if we just factorize this, F will be equal to 800 into 5.2 plus 500 into 5.2. So we have 5.2 times 800 plus 500. So F is equal to 5.2 times 1,300. And that will give us 6,720. So if you are not asked for this T at all, we can work it straight. The total mass is 1,300, and we have seen this force, resisting force. So we just add the resisting force plus NA. And what is our resisting force? Which will be 5 into 130 plus 0.2 into 130. So it gives us the same answer. So we are just trying to tell you that when you look at it, there are, just make it simple for yourself. A wedge with a smooth surface and two masses by light string over a smooth pulley. The strings, a wedge with smooth surface and two masses connected by a light string over a smooth pulley. The strings run parallel to the wedge surface. Find the acceleration of either mass and the tension in the string. This is the figure illustrated by the illustrating the question. Now, we have seen how to resolve weights along the inclined plane and perpendicular to the inclined plane. So that's what we also play out here now. Looking at this, we have 3g sine 30. Here also, we have g sine 30. And t will act to resist this one. The t here will pull this one up. So we can see we have two sections now. But A for the two is equal. Now, let's look at this first section. Let's call this 1 and this one 2. So we have 3g sine 30 degrees minus t, because this is the effectual force here now, will be equal to 3a. T minus g sine 30 is equal to a. Now, if we add the two, we are going to have this one cancel this one. We are going to have 2g sine 30 is equal to 4a. And what is sine 30? You know that sine 30 is half. So 2g times half. So this one and this one comes. So a is equal to g over 4. So the acceleration is towards this place. And this one, it will pull this one up. It's a of g over 4. And we have the tension in the string. This one is 9.8 here, 9.8 over 4 meters per second. We are now asked t. We can conveniently find t by either this place or this place. And we can now say t equals to a plus g sine 30. which is equal to 9.8 over 4 plus 9.8 over 2. So this one will give us 2, 4, 6 times 9.8. Okay, let me straight. So that one will be 3 over 4 times 9.8. And what does that give us? So you can see A is 2.45 meters per second square, and C, tension is 7.35 Newton in other case. And as I told you before, you can also look at it from the perspective of whole this thing. If you know the effective force, which is 3G sine 30, the opposing force here is G sine 30. So 3G sine 30 minus G sine 30 will be the total net force divided by what is the total mass 4. You get your A. So what I'm saying is, in this instance, you consider everything as whole rigid body, and it's being moved like this. So the force of G sine 30 is acting against this one. So you have 3G sine 30 minus G sine 30 is equal to 3 plus 1A, which is 4A. We have this one is the masses, the total mass. So at the end of the day, you are going to have 2G sine 30 over 4 is equal to A. And just like what we did here, is equal to G over 4. So very simple and straightforward. Then you can easily find your T. Now I have a question. It says a non-uniform beam length 2.5 meters and weight 80 newtons is attached to a hinge at a wall. Its CG, center of gravity, is 1 meter from the wall. What vertical upward force applied at the other end will keep the beam horizontal? What is the reaction at the hinge? You can easily see that the force acting there is perpendicularly downward. So the forces upward too will be equal to the forces downward, just from the principle of equilibrium. So let's start. R is reaction at the beam, at the hinge rather. P is the force applied. Therefore, R plus P is equal to 80. We are also asked, so we can also use from principle of momentum at equilibrium. At equilibrium, clockwise. Principle of moment. Sorry. From the principle of moment at equilibrium, clockwise moment is equal to anti-clockwise moment. So let's look from here. What is our clockwise moment? P times 2.5. Sorry, our anti-clockwise moment. What's our anti-clockwise moment? P times 2.5. What's our clockwise moment? 80 times 1. So P is equal to times 4 over 10. So this is 8. So this one is 32 Newton. And R, the reaction will be equal to 80 minus 32. 48 Newton. This one is straightforward. This one is straightforward. A uniform plant 2 meters long and weighs 90 Newton rests inclined at an angle of 30 degrees to the horizontal. With one end on a rough road, it is supported in this position by a force applied to its other end at right angles to the plant. Find this force. So this is what we have. We have this rough place. And since it is a uniform plank, the weight, 90 Newton, will act through 1 meter here, 1 meter here. And we are told that it is kept in this position by a force applied to its other end at right angle, which means the force is like this. Let's make it F. Find this force. We have this place to be 30 degrees. So let's call this place R. So moment about R. Moment about R is equal to 0. Therefore, our clockwise moment is 90 times 1 cos 30, because it is this one times this place times this, the perpendicular distance of this one from this place. So 90 times 1 cos 30 is equal to, you can see it is perpendicular straight on this bar, on this plank. It's equal to F times 2. Therefore, F is equal to 90 over 2 cos 30, which is 45 cos 30 degrees. And that would be, so that is 38.97 Newton. So you can see it's very straight. You must just consider the perpendicular distance from the point you are taking your moments to the force, to the line of action of the force. A beam A, B, C, D, E, F rests on two pivots at B and D. The weight of the beam is 300 Newton, and weights are attached at A and E as shown. Find reactions at the pivots. You can see that we have 80 Newton at A, we have 300 Newton as the weight of the beam, and 100 Newton at E. 100 Newton at E. So from equilibrium, we can see that, let's first of all look at this one. Let's say this one is P and this one is Q, as in the reactions at B and P respectively, at P and Q. From equilibrium, we can say forces P plus Q is equal to 80 plus 300 plus 100. That is upward forces equal to downward forces. Upward forces equals downward forces is equal to 480. So P plus Q equals to 480. Now, for E, let's take moments about P. For moments now, clockwise moment will be equal to anti-clockwise moments for equilibrium. So let's take moment about P. No, about B. Moment about B. Let's look at the clockwise moments. We have this one, 300 times 1.2. Let's look at another one. Q, okay, Q is anti-clockwise. 100 times, this one is 2.2, 2.7 will be equal to, you can see, Q goes like this, Q times 2.2 plus 80 times 0.6. You know, this 80 will have anti-clockwise effects. This Q2 will have anti-clockwise effects about B. Now let's sum it out. You have this one as 360 plus 270 is equal to 48 plus 2.2 Q. Now let's work this out. So I got it to this place. So I got 582 equals 2.2 Q, and Q is 264.55 Newton. P from this place, I'm able to get P to the 215.45. So the reaction at D, that is P is 215.45, and at D is 264.55 Newton. A beam AB 5 meters long is balanced horizontally on two supports P and Q, so that AP is 0.6 meters and QB is 1 meter. It is found that if a child of mass 25 kg stands on the beam at either end, the beam is on the point of dumping. Find A, the weight of the beam, B, the distance of the CG from A, and C, the distance from A at which the child must stand for the reactions and the supports to be equal. From the information we have, you know that the beam is 5 meters long, AB. And we are told that it is balanced on two supports. Here we have P, and we are told that this is 0.6 meter. And we have Q here. And we are told that this place is also 1 meter. 1 meter. Then the CG from A, let's call it X. So it will be 5 minus X from B. 5 minus X from B. Now, we are now told that a child of 25 kg, if the child stands on the beam at either end, the beam is on the point of topping. What does that mean? It means that if the child stands here, the reaction here will be 0. If the child stands here, the reaction here will be 0. So we have to find the weight of the beam. So let's work on that. Taking moments. Since we can see that if the child stands here, 25 kg, this place, the reaction here will be 0. The reaction here will be 0. So let's take the moments about Q. Let's put the child here now. So the moment here about here, this space will give us 0 now. So we are going to have, and the distance from here to here is now going to be 4 minus x, because we have already removed 1 to the other side. So we are going to have w into 5 minus x minus 1 will be equal to 25g times 1. Please, the reaction here is 0 this time. So we are going to have w into 4 minus x is equal to 25 times 9.8. That one goes like that. Now let's now shift this 25 kg baby to this place. So let's take the moment about this place. 25 kg times 0.6. 25 g times 0.6 will be equal to w, w into x minus 0.6, because the distance from A is x. W into x minus 0.6. Please take notes. Take notes. This one is moments about Q. Moments about P. And from here, when the baby acts here, P is 0. When the baby acts here, Q is 0. That's it. The reaction here is 0. So that is what we are working on now. Now let's bring out the whole thing now. So we have 4w minus ws is equal to 25 times 9.8. Here I have 25 times 9.8 times 0.6 is equal to ws minus 0.6 w. Now, if I add this one to this one, let's see what it is going to give me. That's what it's going to give me, because this one you cancel out. I'm going to have 3.4 w will give me 25 times 9.8 times 1.6. So the weight of the beam w will be equal to 25 times 9.8 times 1.6 over 3.4. Let me work that out. Now, the weight of the beam. The weight of the beam is 115.3 Newton. Now, for me to get the distance of the CG from A, let's work it out. I have 25g times 0.6 is equal to 25 times 9.8 times 1.6 over 3.4. This place into x minus 0.6. So from here, I will be able to get x with little error. So I can cut this. So x minus 0.6 will now be 0.6 times 3.4 over 1.6. And this will give me. So you can see, after cutting it here, I brought x minus 0.6 up here. So I have been able to get x minus 0.6 to 1.275 meters. So x equals to 1.275 plus 0.6, that is 1.875 meters. So we have gotten two of the three questions. We have gotten the distance of the CG from A and the weight of the beam. So we have gotten that one now. Now the last part says, now you calculate the distance from A at which the child must stand for the reaction and the support to be equal. So we have gotten the weight, we have gotten the distance of CG from A. So we are now trying to find the point at which the child will stand for the reactions to be equal. So let's make the child stand at, let's say, y from A. Let's say y, okay. Let's say y from P. Okay, let's make it that way. Y from P. So, P from A is 0.6. Now let's work it out. This one is 25g downward. So the total force upward will equal to total force downward. Therefore, P plus Q will equal to 25 times 9.8 plus 115.3. That is P plus Q. But we are told that for P and Q to be equal, therefore, P is equal to Q, which is equal to 25 times 9.8 plus 115.3 over 2. That is our P and Q. We will now be able to get our moments now. Let's take moments about P. Let's take moments about P. We have this force P and Q times the distance from here to here is 3.4. 3.4 will be equal to the distance and W times, what is the distance here? 118.75 minus 0.6. 1.275 plus 25G times Y. And we know what our G is, 9.8. Therefore, you can now say 25 times 9.8 plus 115.3 over 2 times 3.4 is equal to 115.3 times 1.275 plus 25 times 9.8 times Y. So P equals to Q. I got it to be 180.15. I divided this one by 2. Now Q times 3.4 equals to W times 1.275. We have gotten that one here. From here to here is 1.875 minus 0.6. That one is it. And 25G times Y, that is the distance from, since the moment is about P. Moment about P. The moment about P. So it gave us this from here. And 115.3 times this. Therefore, Y is equal to 180.15 times 3.4 minus 115.3 times 1.275 over 25 times 9.8, which is equal to 1.9 meters. And you can see that we took it from P. P from A is 0.6. Therefore, position of charge from A is equal to 0.6 plus Y, which is 0.6 plus 1.9, 2.5 meters. You can also take the moment about A itself. You can take the moment about A itself. So this one we have moment about A, this one we have moment about it, this one we have moment about it, and this one too we have moment about A. Let's see how it goes. Taking moment about A. The other one was taking moment about the pivot P, about A. So we got this one to be P plus Q is equal to 25G plus 115.3. I got that one to be, I think, 180.15. That gives 360.3 Newton. And we know that P equals to Q, and which is equal to 360.3 over 2. And that is 180.15 Newton. So, taking moment about A now, we are going to have 180, that is clockwise. P, okay, let me make like this. P times 0.6 plus Q times 4 will be equal to W times 1.875 plus 25G times, let me just on Z. The distance of this 25 from here, let me make it Z. From A, Z. Therefore, we know what P is, we know what Q is. So we have it to be 180.15 into 4.6, because these two are equal. Will be equal to 115.3 times 1.875 plus 25 times 9.8 times Z. Now, so to take the moment about A directly, this is how it pans out. P times 0.6. So this is clockwise moments, and this is anti-clockwise. So at the end of the day, Z came out straight at 2.5 Newton. The diagram shows the painter in the crate, which hangs alongside the building. When the painter, who weighs 1,000 Newton, pulls on the rope, the force he exerts on the floor of the crate is 450 Newton. If the crate weighs 250 Newton, find the acceleration, the tension in the rope, and the reaction at the axle. So this one is usually called boson arrangement. Now, we will take it one by one. Let's first of all consider the first diagram on the painter. This is the painter. Okay, let's use it to represent the painter. He's holding on this rope, T, and he's moving with acceleration, A. So, the total force that is supposed to exert on this place is Ng plus Ma. Ng plus Ma. But C is now pulling him up, which reduces the total force is supposed to exert on this place. So at the end of the day, the total force he exerts on the crate is 450. So this is about the painter. Please let's take that one as equation 1. So mass of the painter, MP painter, and G plus MPA, that is acceleration, minus T is equal to 450. Now let's consider the crate itself. Now if you look at the crate, this is the crate. There is a tension here at the same time. This one. This is the first one I talked about. Now I'm talking about this. But the two of them are equal. This tension now is moving this body up with acceleration A. This is the total force. It's supposed total tension. Yes, we are supposed to have it. But at the same time, there is additional 450 from the weight of this man that acts on it. So we have this one plus 450 that gives us this. Therefore, we have MCG plus MCA plus 450 equals to T. Now, if you look at the whole arrangement, this one is equal to this 2T is equal to MPG plus MCG. G, please, G is acceleration due to gravity, plus MPA plus MCA. You understand? So which means that the total force on this one is equal to the weight plus the force due to acceleration. Therefore, 2T is equal to MP plus MC into G plus A. Now, let's clarify everything now. So MP is equal to W by G. Where G is equal to 10 meters per second square. So we have this one. This is for the painter piece. This subscript P is for the painter. So we have 1000 over 10, which is 100 kg. MC is equal to WC over G, 250 over 10, and that's equal to 25 kg. What else are we looking for? Yeah. That's the main thing. And G, we have known what G is. So now let's substitute here. So MPG is 1000. We have gotten down. MPA, that is 100A. Minus T is equal to 450. Here we have FC is 25. So that one is 250. FCA is 25A. Plus 450 equals to C. At the same time here we have this 2T is equal to MP plus this one, that is 125. 100 plus 25 and into G plus A. So we can also say it's equal to 125 plus 125 A. So we can use any of this to solve this. So we can call this one 1, 2, and 3. Now, since this one is T, I can easily substitute this one here now. So I have 1000 plus 100A minus 250 minus 25A minus 450. So, okay, plus equals to 450. Equals to 450. Therefore, I can say 1000 plus 100A minus 250 minus 25A minus 450 equals to 450. So, I am substituting this one into this place. So, what do I have next? 1000, this one and this one is 700. So I have 300. This one and this one is 75. Is equal to 450. So subtracting 300 from both sides, I have 75 is equal to 150. So A equals to 150 over 75, which is 2 meters per second. So which means it moved up with acceleration of 2 meters per second. Now let us find the tension. C. We can find this straight from here. Since we have gotten A. So T will be equal to 250 plus 450 plus 25 times 2. And what does that give me? 250 plus 150, that's 700. Plus 25 times 2. So T equals to 750. 750 newton. Now, R here is equal to 2T. That is the reaction at the atom. So let me call that one R. So R is equal to 2T. E is equal to 2 times 750, which is 1500 newton. So to confirm, you can substitute A here, and you can see it gives us the same thing. The foot of a uniform ladder is on a rough horizontal ground, and the top rests against a smooth vertical wall. The weight of the ladder is 400 Newton, and the man weighing 800 Newton stands on the ladder, 1/4 of its length from the bottom. If the inclination of the ladder to the horizontal is 30 degrees, find the reaction at the wall and the total force at the ground. Now let's draw it. We are going to have something like this. So this will represent our ladder, and this represents our rough ground. So this is the ladder now. Because it is uniform, the weight of the ladder will come from the middle, that is L over 2. From this place to this place will be L over 2. So this is 400 Newton now. We also told that a man weighing 800 Newton stands 1/4 from this place. So which means that from here to here now, we are going to have L over 4. So we can get it by drawing the diagram straight, or by analysis using finding the moments and whatever, and adding the forces. So let us use drawing the diagram to get it. Now to get the center at which the total force acts here, we are going to find the total moment about the point, find the total force, and then get the point at which it will act through. This is L over 4. This is L over 2. And from here to here too will be L over 4. Now let's find the moment about this place for these two forces. Yeah, before I go on, please, because the wall is smooth, the reaction from the wall will be perpendicular to the wall. It is smooth. So we have F here and we have R here. Because it is rough, R will not be perpendicular. Now, let's quickly work this out. The point at which the total force, horizontal force will act from. Now, total vertical force. Total vertical force. Let me call that one N. So N is equal to 400 plus 800 because they are in equilibrium. So this 1200. So let's find the moment about this point G. Let's call this one G. Let's call this place W because it's ground and the wall. So moment of vertical forces about G is equal to 400. Please, this is 30 degrees. So it will be 400 times L over 2 cos 30 degrees. Please, from this place to this place. This is it. So that is what we take. Plus 800 times L over 4 cos 30 degrees. So, and what does that give us? It is equal to 200. 200. So we have what now? 400 L cos 30 degrees. That is the moment. And it must be equal to the moment of total vertical reaction force here. It is equal to 1200 x. That is the distance from here to here. X. It has been explained in the lecture. So x is equal to 400 which is equal to L over 3 cos 30 degrees. So what does that mean? It means that from here to here is L over 3 cos 30. L over 3 cos 30. Now if we want to draw this diagram now, we are going to have, and you know that this place is L sin 30. Let's now draw the diagram. We know what this is. So this one will go like this. R will go like this. This will go like this. This is 1200. And this one will be like this. That is F, the reaction from the wall. This one you can see. And this is R. This is the total vertical force, and this is F. I will show you another way to get this, so that in case you find yourself in any kind of situation. Now we have gotten this. The forces will be proportional to the length of the side of this triangle from our triangle of forces at equilibrium. Now we say this place is L sine 30, and we say this place is L over 3 cos 30. We have gotten L sine 30 from this place now. So I can get F conveniently now. F over 1200 will equal to L over 3 cos 30 over L sine 30. And that will be N over 3L tan 30. So this one cancels this. Yeah. So F will equal to 1200 over 3 tan 30. Now what is tan 30? 1 over root 3. So I have 1200 over 3 root 3. So this is 400. So F equals to 400 root 3. And now to find R, I can easily find this. Now let me find this angle, the direction of R. Conveniently I can find this from this again. Tan theta, please. Tan theta is equal to this side over this side, and that will be L over 3. Sorry. Tan theta is equal to opposite over adjacent, that is L sine 30 over L divided by L over 3 cos 30, and it is equal to L sine 30 times 3 over L cos 30, and this will give me 3 tan 30, which is 3 times 1 over root 3, and it is equal to root 3. So tan, this angle theta is equal to tan 60. So theta is equal to 60 degrees. So I can use any form now to get my R. I can use Pythagoras theorem, or I can just use this trigonometric ratio. Simple. Now I can find R by saying that R sine 60 is equal to 1200. Therefore, R is equal to 1200 over sine 60. And what is our sine 60? Root 3 over 2. So that will be 1200 over root 3 times 2, which will be 2400 over root 3. And that will be, we know our ratios now, but I want to work this out. So this is 800 times 3 over root 3, which is 800 root 3. So F, that is the reaction from the wall, is 400 root 3. R, the reaction from the ground, is 800 root 3, 60 degrees to the horizontal. So you can use our calculator to find the figures. So using calculator, F, the reaction from the wall is 692.82 Newton. The reaction from the ground is 1385.64 Newton. Now another way you can find this center is by bringing this place out. By bringing this place out, here you have 800 and here you have 400. And the distance here is L over 4 cos 30 degrees. Please let me make this one to be equal to M. Now the center here will be close to 800 and this one. So we know something that 400 A will be equal to 800 B. That will be the shift. We have the total action will be, we have the force to concentrate on. So we have, let's find B. So B over A will be equal to 400 over 800, which is 1 over 2. Please, in case of I'm just doing this so that when you see another scenario, you'll be able to handle it. Now, since we have gotten this, you can now see n is equal to a plus b. So n will be equal to 3b. And you see, therefore, b is equal to L over 4 cos 30 times 1 over 3, which is L over 12 cos 30. After you have gotten this, to find the center now, you have to add this one to this one. Some instances you might not need to, but I'm just showing you how to arrive at the same answer. So we have from this place to this place is L over 4 cos theta. So we are now adding this one to it. So from this place to this place, which I refer to as x the other time. So x is equal to L over 4 cos 30 degrees plus L over 12 cos 30 degrees. So, and it's now giving us, what's the LCM? 12. Yep. This one is 3 plus 1. So everything, since L cos theta cos 30 degrees is common to all. So you have 4 over 12 into L cos 30 degrees, which is 1 over L over 3 cos 30 degrees. So you can see we arrive at the same answer. Let us now use analytical technique that will not require us drawing triangle or forces. We will just do it by calculating, take moment about G here. Because this one is not perpendicular, so it's not easy to take it about any other point. So let's take it about this place. So moment about G is equal to 0. That is, clockwise moment is equal to anti-clockwise moment. So what is the clockwise moment? It is F times, you can see from this place up here, is L sin 30. It will equal to, this is the anti-clockwise, 400 times L over 2 cos 30, you can see, from this place, plus 800 times L over 4 cos 30 degrees. So you can see this one is 200 L, 200 L. So we have 400, so FL sin 30 degrees is equal to 400 L cos 30 degrees. So F is equal to what is 400 cos 30 degrees over sin 30 degrees. So what do we have? We have 400 over tan 30 degrees. And we know that tan 30 degrees is 1 over root 3. So we are going to have 400 over 1 over root 3. Therefore, F equals to 400 root 3 Newton. It doesn't that one out the other time. Now, to find R, we use our knowledge of vector. What is our total horizontal force? And then vertical force is 400 plus 800 G. Because this one acts like this. R will act in this way. So let's make it minus. And this one will be minus. Please note, this one acts in this way. This one acts in this way. So to balance it up, F will act against them. Now, so what do we have now? So the component of X in the component of R in the X direction will be equal to, so R X is equal to 400 root 3. Ry is equal to, no, sorry, this one is plus, it's upwards. So Ry is equal to 1200. So R, magnitude of R is equal to 1200 squared plus 400 root 3 squared. And that gives us, so this is what we have now. For us to find our direction of R, tan, okay, let me do this. Theta is equal to R tan Ry over Rx. And this is equal to 1200 over 400 root 3. So you can see that it's R tan root 3, which is 60 degrees. So this one is even faster. A rectangular plate ABCD has two forces of 100 Newton acting along AB and BC in opposite direction. If AB equals 3 meters and BC equals 5 meters, AB, C, and D. We are told that AB equals 3 meters. And BC equals to 5 meters. What is the moment of the couple of drops acting on the plate? What force acting along BC and AD respectively are required to keep the plate in equilibrium? This is very simple and straightforward. We are told that this force of 100 Newton acts along AB and BC. So this is how it's going to be. For couple, we are going to have it like this: 100, 100. That's how we are going to have it. Top of couple, they act in opposite direction. Now, the distance between them is 5 meters. So the distance between them is 5 meters. So the top or top is going to be 100 times 5 Newton meter, which is going to be 500 Newton meter. We are now told that what will be the force along BC and AD respectively required to keep the plate in equilibrium. You can see that this one acts clockwise. So we are going to have this force like this. So we are going to have P to act in anti-clockwise direction. And it must be equal to this one to be at equilibrium. Therefore, the torque of this one is P times 3 should be equal to 500 Newton meter, in the clockwise direction, in the anti-clockwise direction. This one acted clockwise. Therefore, P will be equal to 500 over 3. And that's going to give us 1 in 26. Let's say 167 Newton. 167 Newton.